Alright, in this video we're going to be talking about algebraic expressions. Okay, so this is going to be the next group of questions in the workbook. Alright, so example 10. What is the variable? Well, the variable is the placeholder for an unknown. Okay, in this case, this A is my unknown. I don't know what A is. Okay, so my variable is A. It's a placeholder for something I don't know. Okay, how many terms? Well, terms are separated with these symbols here. Okay, so I have a plus. That's separating my two terms. So my first term is 4A, and my second term is 7. So there are two terms. This is really important for kind of knowing what a teacher is talking about when they use these vocabulary words. You need to know what they're talking about. So in this one, y is my unknown. Okay, don't know what y is. How many terms? Well, a term is only separated by addition, subtraction, or an equal sign. There's only one subtraction, so that's 2, and it's dividing two things. So there are only two terms. Again, division or multiplication, as you see here, those do not separate terms, so that does not make new terms. Okay, multiplication, division does not make a new term, and the reason is because terms are what we combine. And remember, whenever you combine terms, it's kind of like when you're adding fractions. You can only add and subtract terms, okay? Because terms have to be like, just like denominators have to be like, all right? So it's very important to find the common ones. All right, let's look at this example 12. Okay, so in this one, I don't have to combine anything. I can just multiply. Remember, multiplying, go back to your example of fractions. When I add and subtract fractions, I have to have a commonality, and that is the denominators. When I multiply and divide, I don't care. Just multiply across the top, multiply across the bottom. Same with expressions. If I'm adding and subtracting them, they have to have something like, and that thing that's like has to be the variable or the lack thereof. The variable has to have the same degree as well, degree of power. But when I'm multiplying and dividing, I don't care. All I do is multiply my coefficients and drop down my x. Why is that? Well, okay, so we know that all of multiplication can be reduced down into addition. So this is saying I have two 7x's added together. Look, they're common. Multiplication always brings it back to a common term without us even having to worry about it. Okay? Makes them like terms. So that is why we don't care in multiplication if they're like, because if I put it down into addition, it's always going to be like. Isn't that beautiful about math? All right, so let's look at this next one, and this A should not be here. For some reason, whenever I render it from PDF, it does all kinds of weird things. So the A's doubled. So I really have A minus 5 minus 3A plus 10. So my like terms would be these A terms. And I got to take the sign that's in front. Okay, let me highlight them in red. So this is a positive A, and this one's a negative 3A. Okay, so now I'm just going to do some addition where I take the coefficients, and I'm going to just do that. Okay? So I take these coefficients. 1a, remember, I can say that there's an understood 1 in front of that. And I take my 3a and I'm going to put them together. So positive 1 minus a 3 is going to give me a negative 2. Now that a doesn't become an a squared. It's kind of like in fractions. I don't say 1/5 plus 2/5 is 3/10. No, that 5, that's the comparable element. It's the thing that's like. It's just along for the ride. Same here. That A is just along for the ride. All right, so we have some other like terms. Let me change my color. So I have a -5 and a +10. Because they don't have terms, they lack variables, not terms, variables. They are also like terms because they lack a variable. So a -5 plus a 10, we should know our stuff now. That's going to be a 5. And it's going to be positive. Okay? And so we can't reduce this anymore. And so we're just done. We're done. I can't combine the -2a with the 5. They don't share the same variable. So that is my ending answer. Again, my thing keeps doubling these variables. All right. So our like terms are going to be the 9, and it's going to be positive, and this +12. And that is going to give me 21. We also have a -m, which could be written as a -1m and a -6m that are also like. And when I combine them together, they are both negative, so I add. That's going to give me 7, and it's going to be negative. So 21 minus 7m. Okay, in this one, none of the terms are like. There is nothing I can do with this one because, remember, it has to be the same variable with the same degree of power. This has a degree of power of 2, and this one doesn't have anything written, which makes it an understood 1. Whenever something isn't written, it's understood to be a 1. Okay, in math. Okay, that's the identity property. Okay, so I can't combine anything because none of them share a like term. So this is the answer. In this one, nothing shares a like term with that a squared because none of the other a's have a square in it. Okay, so that one's just done. I'm going to write it in my ending answer. But these two terms are like. Okay? Because they both have the same variable with the same degree of power, and that is just plain old A. Alright? So 54A minus 4A is going to give me a positive 50A. And the last thing is this negative 36. There is no other term that does not have a variable, so it just hangs out back here. All right, and again, nothing is like with the 7y squared. Nothing is like with the -6, but these two bad boys are like. So a plus 21 minus a 2 is going to give me a positive 19y. Then I just dropped everything down. Make sure you put your positive here because it's a term. It has to have an addition, a subtraction, or an equal sign dividing it. You know, breaking it up. So this one has some really crazy stuff going on. Okay, let me change my color. So this first one, -2y. Okay, the only other thing that's like with it is this -24y. I can't say it's like with the 5xy because that term has two variables in it. So it would only be like with other terms that both have an x and a y, no matter what order that x and y comes in, it would only be like with terms that have both in it. And I don't have any other terms with both in it. All right, so they're both negative, so I add, taking the sign. Now let's do our next one, our x's. So the 7x is only like with this negative 4x, not with the 5x, y. Okay, so they have different signs, so I subtract, and the bigger one is positive. And then nothing is like with this one, so it just gets dropped down. Notice we're not actually solving anything with expressions. That's because we don't really have an equal sign. We can't. Alright, so in this one, the t term is like with this t term and this t term. Okay, so negative 5 plus 10 is going to be a positive 5t minus the 2t. And I'm going to come out here and write my answer. And so 5t minus 2t is going to give me 3t. We should know those negatives and positives now. I went over them in the part 1. So if you need more help, go back to the part 1. Alright, when I put these two together, I'm going to add because they're like in their sign, and I'm going to get a positive 14z. The distributive property, and this is all messed up because of my formatting. Alright, so the distributive property says the parentheses also mean multiplication. Instead of using it to say I have to add b plus c first, I could say that it means multiplication. It means a is multiplied to b plus c, which means a is multiplied to everything inside of b plus c. The a is multiplied to the b, and the a is multiplied to the c. Now, when we're doing an expression like this, it doesn't really matter. It is quicker to just do what's in the parenthesis and then do it straight back. That's called a numeric expression. But when we're doing algebraic expressions with an unknown, it's the only way that I can solve it. Because look here, x plus 3. I can't do x plus 3 because they're not like. But in multiplication, they don't have to be like. So we use this distributive property to kind of backdoor get around the fact that I can't do what's in the parenthesis. Now I can say that 5 is multiplied to the x and 5 is multiplied to the 3. Notice I don't drop the operation of addition. That is still very much important. The x is still being added to the 3, just in a more roundabout way. Okay, we're applying our multiplication first. Okay, so let's clean this up. 5 times x, don't overthink it, it's just 5x. All right, and then 5 times 3 is 15. Again, with this one, we're going to distribute this 3 through in multiplication. 3 times 7 is 21. All right, so in this one, let me rewrite it correctly. We're going to distribute a negative 6. Make sure you take the whole negative with you whenever you're doing this one. Okay, so negative 6 times a negative 3x is going to be an 18. Two negatives in multiplication make a positive, and it's an x. negative 6 times a negative 6y, okay? So this negative is going to drop down. We're going to multiply it to the negative 6. All right, we got to distribute it through. So that is going to be 6 times 6 is 36. Two negatives make a positive, and the y is along for the ride. Next one. That positive comes down. We're going to multiply it to the negative 6. Negative and a positive make a negative. 8 times 6 is 48. Now I can't do anything else with that because they all have different variables or no variables, okay? All right, let's do the next one. All right, so we're going to do negative 7c times the negative 2. Drop down my sign. Negative times the negative 2. Next term times the negative 2. Look, I multiplied everything by the negative 2 because that's also what that parenthesis means, okay? All right, so a negative and a negative make a positive 14c. All right, a negative and a negative make a positive 8d. A positive and a negative make a negative 2. Nothing is like, so we are done. All right, so another important skill to remember is that if there is no number at the outside of my parenthesis, I still got to multiply that negative through. And the number that is actually there is the understood number of 1. Remember, that's just always understood in math. It's redundant, so I don't put it there. All right, so we have x times a negative 1, drop down my sign, 10 times a negative 1. I multiply that by everything. X times negative 1 is just negative x, or you could put a negative 1x, it doesn't matter, plus a negative 10, or I could write it as negative x minus 10, or negative 1 minus 10, or negative 1 plus a negative 10. These are all correct ways that mean the same thing. So I'm just going to throw in my 1 because I know it's there. And I'm going to multiply it through. So a negative 9s is multiplied to a negative 1, and a negative 3 is multiplied to a negative 1. Watch what it does, okay? So a negative 9 times a negative 1 is going to give me a positive 9s, and these two are going to turn to a positive 3. Look, it changed the signs of everything in the parentheses to positives. So that's another way I could look at it. I could just say, I know it's going to change the signs. Let's kind of do that way in this one, right? So I have 4. So this is what I have. So in this first parentheses, everything gets multiplied by the 4. Drop down my symbol. Okay, and I'm just going to work out this part, and then I'll go back and write the rest. All right, so that's going to give me a 4x plus 5 times 4 is 20. All right. So the negative 5, I can't do anything with it because I got to work that multiplication out first, so it's just going to go along for the ride. All right, so this last one, I'm going to assume the 1. All right, write that in. So it is going to be the negative 1 times the 2x, drop down my symbol, times negative 1. Okay, so it's just going to change everything. The 2x becomes negative, and the 4 becomes positive. All right, now I got to find my like terms. So I have this 4x and this negative 2x, and if I combine them, I'm going to get just a positive 2x. And then I have a ton of what we call constant terms. They have no variable. So I have 20 minus 5, which is going to still be plus 15, plus the 4. My answer is going to be 2x plus 19. All right, we only have a few more, so let's go ahead and hurry up with those. I'm going to try to change, yeah, got there. All right. to go ahead and just put my understood one in off the bat. Alright, so in this first one, I'm going to take 6 times 3y, drop down my symbol, and take the 6 times that too. It doesn't matter where I put the 6, it still means multiplication. And now I'm going to multiply everything by my negative 1. Alright, let's clean it up. 18y minus 6 plus 2. Do this multiplication, which is a positive 3y, and that's a negative 4. And I'm doing my multiplication first because that's what would come first in order of operations. Let's combine my like terms. Alright, if I combine those two, I'm going to have 21y. And then all my constant terms are going to give me a negative 8. Alright, so let's treat this as it just changes the sign of everything, because that's the other way we could look at it. So the t is positive here, it becomes negative when it comes out of the parenthesis, and the 8 is negative, so when it comes out of the parenthesis, it becomes positive. Combine these two like terms, and I have 2t plus 8. Just a few more. Let's distribute. So negative 4 times negative 4y. Bring down my symbol. Negative 4 times 5. Okay, plus 4. Negative 6. I got to take that negative in front of the 6 when I distribute it through, so don't forget that. Negative 6 times y plus 2 times the negative 6. Cannot forget that negative 6. Let's clean it up. Two negatives make a positive, 16y. Negative and a positive make a negative 20. Negative 6 times y is a negative 6y. Positive 2 times a negative 6 is a negative 12. Let's get these y's together. It's going to give me a 10y. It's going to give me negative 16. Oh, and I have a negative 12 at the end, which is going to give me a negative 28 and a 10y. All right, just 3 more. All right, so we've kind of gone through everything, so I'm going to do this one, probably the rest of them, super fast, because they're just practicing the same skill over and over again that I've explained a few times now. So I'm going to bring through my 5 multiplying. Clean up my multiplication. Combine my like terms. And then my ending result is 23 minus 3s. All right, 2 more. Alright, let's distribute through. I'm actually going to get faster with my distributing. I'm going to do it all in one step, because we should be getting faster and faster as we go along. Alright, one last one. Okay, understood one here, so it's going to be negative u minus 2. I'm going to distribute through. 5 times 6 is 30. 5 times u is, a negative u is 5u. Oh, that's a z, sorry. Z, and then the only like terms I have are right here. So it's going to be negative u plus 28 minus 5z. All right, so the next video we'll do the next few examples. This one just was 10 through 32. Let me know if you have any problems.